Hello everyone. Today we'll discuss about multidimensional scaling. In short, we call it MDS. So this is our outline. These are our agenda points. We'll discuss what is multidimensional scaling, that is MDS. What are the objectives of MDS? What are the types of MDS? What are the application of MDS? And we'll consider research design for MDS. Then we'll consider assumptions of MDS. And finally, we'll study the case studies related to multidimensional scaling, that is MDS. Now, what is multidimensional scaling? So you can see here, multidimensional scaling is a set of data analysis technique used to explore the structure of similarity or dissimilarity data through visual display. So through visual display, one dimension, two dimension, three dimension, through which we will find out. Now the second point, it is saying MDS represent a set of objects as a point in a multidimensional space in such a way that the points corresponding to similar objects are located closer to each other. So though the objects which are similar to each other, that will be closer together, while those corresponding to dissimilar objects are located far apart. So this is the basic definition, that is in the multidimensional scaling. So the similar objects will be close together and dissimilar objects will be far apart. Now you can see here the multidimensional scaling is also known as perceptual mapping. So you can see here there are three dimensions. This is the x-axis, one dimension, y-axis, second dimension, in the z-axis, third dimension. So we have taken the different brands of toothpaste. So in x-axis we have taken the Fights cavities, y-axis we have taken the whitens teeth, and z-axis we have taken freshness. So in this is the perceptual mapping in the multidimensional space. So you can see here Colgate and Aquafresh are similar, so they are in the 4 quadrant. Then you can see here the close-up, Crest and Aim are in the first quadrant, and again Aim and Crest are very nearer, so they are very similar product. Whereas you can see here the Ultra White and Aim or the Crest are very far apart, that is that they are not similar product. So these are the things through which we can find out which are the area in which the quadrant our product is positioned. And then you can see here the Gleam and Pepsodent, these two products are similar. So in this way we can find out the segmentation of the product, how these products are segmented, how these products are positioned, different brands are positioned, and then also we can find out the gap also. And where once we will find out the gap, then we can do the new product development. So it is for the market segmentation also. You can see here, you can segment the market where the products are there. You can see here the different positioning of the product, as well as you can find out the gap of the product where it is not positioned. What are the from the different brands? Now what are the objectives of multidimensional scaling? The first, as I have discussed, position of the product in a perceptual map of major competitors. So where is the our product or our brand is positioned with respect to our competitors, that we can find out. We can find out the positioning of our product, and also assessment of the preference towards XYZ product relative to the major competitors. Also we can find out what is the preference level of our product, how the customers perceived about our product with respect to our competitors. Then you can see here there are types of multidimensional scaling. So multidimensional scaling are of two types: metric MDS, where we use the interval and ratio scale, and under metric MDS we talk about the classical multidimensional scaling. In classical multidimensional scaling we consider only one matrix. And second is weighted multidimensional scaling, in which we consider the several metrics. So under metric MDS we consider interval and ratio scale data, and in which there are two types, one matrix and second is for the several metrics. If our data is of non-metric, that is the ordinal data, then it is known as the non-metric multidimensional scaling, like the ranking of Bollywood stars and all these things, and we can find out their perceptual mapping given by the respondents. So we can find out through the ranking value, then we can say it is a non-metric MDS. This is ordinal. Now you can see what are the assumptions required in case of multidimensional scaling. The first one, we are talking about the object should be comparable. Means we should compare the products and we should find out the perceptual map of different brands or the objects related to the very similar products. We cannot compare like Nano and Mercedes. then these two products are different. Their positioning is different. Definitely their positioning is different. So the similar type of brand, similar type of objects we should compare. First point. Second assumption is representativeness of the objects. Whatever the objects or the brands available in the market, we should consider the brands or the object that should cover at least 70 to 80% of the market share. So such type of brand we should consider. We should not take like only whatever the brand we are comparing and we are finding the perceptual mapping, only 25% market share is covering such type of objects or the brands. So it will not work. So at least 70 to 80% the objects or the market share should be covered by the brands. Then we are talking about what is the application of the MDS, multidimensional scaling. The first thing we are talking about the image measurement. So we'll find out the brand image of our product, our brand with respect to our competitors through the perceptual mapping. Second, also we can find out the brand positioning, our positioning of our product with respect to other competitors. That also we can find out. Then we can find out the market segmentation, how the different companies has segmented their product for the different cluster of customers, and where is our position, where is our brand. So that also we can find out in which cluster it is there. Then once we will do all these things, brand positioning, market segmentation, then if there is a gap in the positioning and then some space is there, then we can do the new product development also. New product development on that particular gap, we can find out one product and we can launch our product on, and we can position our product for from our company. Then you can see the assessing the advertising effectiveness. We can also find out what is the advertising effectiveness of our advertisement done by our company with respect to the other companies. Also we can see the pricing analysis. What is the pricing of our product or our brand with respect to competitors? And lastly, the channel decisions. What are the channel we have adopted with respect to our competitors? It is correct or not? And we can take the responses from the respondent and we can find out. So these are the various applications of multidimensional scaling, and we can do it through perceptual mapping, or you can say that the multidimensional scaling. Now the research design for MDS. What we are talking about, the first thing we are talking about, attribute free method. The multidimensional scaling, or you can say that the perceptual mapping, it is a attribute free method. What does it mean? Attribute free method means what? If we are talking about any particular thing, if we are asking the customers or the respondent about the responses given by them, we will not given any criteria or the attributes like the price, quality, whatever it may be. We will just ask the respondent their overall perception about the product, our product, with respect to other competitors' product. So we will do the paired comparison of the products, overall comparison. It is attribute free. We will not ask them related to any attribute. What is their overall perception? So that's why we are talking about it is a attribute free method. Now we are talking about the selecting the objects and number of objects, that I have already discussed in the previous slide, that the object should, at least the brand or the object should cover 70 to 80% of the market. So we should consider all the objects, we should cover 70 to 80% market. And we compare the product on the basis of similarity or dissimilarity. If the products or the objects are similar, then they will come closer. And then if they are dissimilar, then they will far apart. Now the rating should be given on same dimension. This is one of the problem when we are taking once what we have said, it is a attribute free method. Means we are not asking the respondents that in which parameters you have to give the responses. We are not saying that on the basis of quality, on the basis of price, or on the basis of easily available. What are the parameters? We are not saying all these things to the respondent. So we have to see this. So if we are asking more than one customers, or we are taking the responses from 100 respondents, so how we'll see that all the respondents have given the responses on the same dimension? So that we have to identify and we have to take care of that particular aspect. Otherwise, you can give certain idea to the customers or the respondents that in this criteria you have to get. But actually this is a attribute free method. But to avoid that, because they will one respondent will give the responses on some other criteria, and then the other customer will get, or the respondent will give on the other criteria, so there will be a mismatch, so it will be difficult for us. So how, and then I am saying that it is a attribute free method. Then how you will identify the dimension, that in x-axis what criteria they have considered, in y-axis what criteria they have considered. So how will identify? You can see a dimension can be identified by showing the map to the respondents. So we'll show, once we'll get the result of the perceptual map, we'll show this diagram to the respondents, and we'll ask them that in which criteria you have given these respondent, and if this particular brand is here, it means that what is in the y-axis and what is in the x-axis, and in this way we can find out the dimension. Now second, how many pair? It is a pair comparison method. So how many, if we have the 5 objects, you can see here, then what will be the number of pair comparison will be, if 5 into 5 minus 1 divided by 2, so 5 into 4 divided by 2, so that will be 10 pairs will be there. So where n is the number of objects, or you can say that the number of brands we are comparing, or you can say that the companies. So one important thing we are talking about, multi-dimensional scaling can be used for a single respondent also. You can do the multi-dimensional scaling for one respondent and individual for an individual also. And the aggregate multi-dimensional scaling you can do, always you can do. So more number of respondents also you can do. But for a single respondent also you can do multi-dimensional scaling. And we have one example I will show you. Now, what are the MDS results and assessing the overall fit? So dimensionality, how many dimensions should be required in case of multi-dimensional scaling? The name is multi-dimensional scaling, but dimensionality of the solution in most of the time we consider it is 2 dimensions. So it is easier to explain, or maximum you can say 3 dimensions, not more than 3. If we will take more than 3, it is difficult to explain. So normally we take 2. Now how we'll find out that our model is good? So we have to find out the stress value. It is known as the badness of fit. So always when we are talking about the badness of fit, means the value should be less. So 10% is acceptable. If it is more than 10%, it is not acceptable. So what it is saying, if your stress value is 0.20, means it is 20%, then it is poor. 0.10 means it is 10%, then it is fair. 0.05, 5% means good. 0.025, 2.5% means excellent, and 0.000 means it is a perfect. So it is very difficult to find out perfect value. Also, another thing to find out the fitness of the model, that is the R square, that is equal to R square, that is the goodness of fit. A high value of it is a goodness of fit, R square is goodness of fit. So higher value of R square is always better. Minimum our R square value should be 0.60. It should not be less than 60%. So these are the criteria in which we find out how our model is. Now we'll consider one example. We are considering one case study, and you can see here the brand positioning of detergent cake. So it is the classical example, means there will be one matrix. So what it is saying, 8 brands of detergent cakes available in the Indian market is taken, and multi-dimensional scaling is used to determine how the Indian customers perceive them. Also, it is used to find out how many dimensions the customers seem to be considering when they think of these brands. So we are considering how many brands are there? 8 brands are there. So how many pairs will be there? The number of pairs, the number of comparison will be n into n minus 1 divided by 2. That is 8 into 8 minus 1 divided by 2, that is equal to 28. So there will be 28 pairs. So now this is the case study we have. We'll convert this case study into a topic. So you can see here, this is our topic. So what we have written here. So perceptual mapping of detergent cakes with special reference to Nirma and empirical study. So either we can write like this, perceptual mapping, as we know that MDS is also known as perceptual mapping, or you can see here brand positioning of detergent cakes with special reference to Nirma as we know that what is the main application of multidimensional scaling or perceptual mapping is brand positioning and empirical study. So either you can write like this or like this. So this is our topic. Now you can see here on the basis of the topic what we are trying to find out, what are the objectives we have formulated. You can see here to find the comparable brands of detergent cakes. So we have to find out the prominent brands of detergent cakes, those who are covering at least 70 to 80% market share. So that brands we have to find out. So number one. Then second, to determine the brand positioning of detergent cakes. Now through the perceptual mapping, we'll find out the brand positioning of all the detergent cakes. So these are our two objectives. Then you can see here the collection of data through questionnaire. How we'll collect our data? So we have taken our 8 brands. Now we have taken the 10-point scale 0 to 10. So you have to compare like Reen to Nirma. How Reen is similar or dissimilar. So 5 is the middle value. If we are going towards 0, then these two are dissimilar. And if we are going towards 10, then these two brands, Reen and Nirma, are similar. Similarly for Reen and Ariel, again the same concept. Reen and Ariel, again you can see here Reen and OK, same concept. Then you can see here the Reen and Eta, the same concept. Towards 0 it is dissimilar, towards 10 these two brands are similar. Same we are talking about the Reen and Will, then we are talking about the Reen and Trilo. So we are talking about how many pair comparison will be there? 28. So you can see here again 7, Reen and Superbar 501, Nirma and Ariel, then Nirma and OK. Again we'll go ahead, Nirma and Eta, Nirma and Will, Nirma and Trilo. Then we are talking about the Nirma and Superbar, then Ariel and OK, Ariel and Eta, then Ariel and Will, then Ariel and Trilo, Ariel and Superbar 501, then OK and Eta, OK and Will, OK and Trilo, then OK and Superbar 501, Eta and Will, Eta and Trilo. Then you can see here Eta and Superbar 501, Will and Trilo, Will and Superbar 501, and the last one is Trilo and Superbar 501. As we have 8 detergent cakes, these are the 8 brands, so we have the n into n minus 1 divided by 2. So we have the total 28 comparisons will be there. So you can see here, so one respondent will give, if he will find that the Trilo and Superbar are dissimilar, he will give the value, the responses will be on this side. If he is thinking that this is on the, they are very similar, then he will give in the towards 10. And initially, as we have discussed, multidimensional scaling is an attribute free method. So initially we will not tell them in which attributes you have to give the responses. They will decide the parameter, and at the end we will show them the map, and then we'll ask them in which dimension you have. We will ask them what are the dimensions you have considered in differentiating these two brands. Now you can see a data analysis. Now we'll go to our data analysis. So you can see here our data analysis is this. So you can see here we have written the brand names Reen, Nirma, Ariel, OK, Eta, Will, Trilo and Superbar. This is the responses of an individual respondent. So Reen to Reen it will be 0. Nirma to Reen, what it is saying? It is they are dissimilar. It is towards 1. You can see here towards 0. Then OK and Nirma, it is saying 7. It is towards 10. So they are similar. This respondent has given. So these are the responses given by a single respondent. So you can see here. So this is the string because we have taken the brand name, and this is nominal. All are in scale data. It is in interval data. So we'll convert into interval. Okay, into interval data. It is a string. All are numeric. You can see here. Why it is string? Because we have written the name of the different brands. So otherwise it will be numeric. So all the other data are in numeric. It is in string. So now we'll go to data view, and then we'll go for the analysis. And we'll go to scale. In scale, we'll go to multi-dimensional scaling, proc scale, and click it. And then you can see here one matrix, because we have taken one matrix it is, and then the proximities are in a matrix across the column. There are in different columns the data is there. Then we will define, and in define, going to the define, we'll go to we'll select all the brands, and in the proximities we'll take this on the right hand side. In the model, you can see here, you can consider the interval scale. It is a lower triangular matrix. You can see here it is on the lower side. If the data is in upper side, then we can put the upper triangular, or it is on the you can say that the full matrix you can see. And the dissimilarities, you have similarities or dissimilarities, these two criteria we can select. I am selecting dissimilarities. Now we have to find out the dimension. As we have already discussed, the dimension should be, most of the time we keep 2, or at some certain cases we take 3. So we are just finding how many dimensions are required. So we'll start with 1, and the number are 8, total 8. So we'll put 1 less. In maximum we'll put 1 less. So there are 8 brands. So we are starting with 1, and I am keeping it is 7. So first we'll find out how many dimensions are required. Okay, and then we'll go to plot, and then we'll remove this for some time, and then you can see here the stress, and then click this, and then OK. So directly we'll go to this script plot. So you can see here, so this is the dimension, this is the elbow method. So 1 and then 2, and now it is flat. So we will consider 2 dimensions. So it is showing here, you can consider 2 dimension. Otherwise there will be changes will be there if it is more than 2 dimension. So 1 and then 2, and now there are no changes in the horizontal only. All the data are on the horizontal. So there is this is known as the elbow method, through which we can find out. Okay. So we have got that our dimensions should be 2. So again we'll go to our data. And then analyze, scale, multidimensional scaling. Same thing we have to click. Then in model, we'll do it here. 2, minimum is 2, and also maximum is 2. And then continue. Then in restriction, we need not have to do anything. Continue. Options. This is the thing, stress convergence. So if the minimum, it will converge or it will improve the data till we'll get this value 0.001. If it is less than that, then we'll stop the convergence and we'll stop the improvement. So this is the minimum stress value should be 0.000. It should not be exactly 0. So it is, if you are getting 0.0001, then it is almost it is a perfect model. Then maximum iteration will be 100. So till it will be improved till like your convergence is less than this, the 0.0001, then it will stop and it will go up to 100 iteration. So before that, in 4, 5, 6, 8 iteration only you will find out this value, and then the total number of convergence or improvement will be not more than 4, 5, 6. Okay, and then continue. I will show you once we'll get the data also. And then the script plot, we'll find out the common space. Okay, continue. In the output, all these values are there, and then continue. Okay, so you can see here, we'll see one by one. So data scaling group, all these things are there. First will come the total number of cases. The total number of cases are, you can see here, total number of cases are 8. So there are 8 brands. So source, that is only 1. Objects are 8. So the total comparison proximities are 28, and there are no missing proximities, no missing values are there. So it is 0, and the active proximities are there, that is the 28. Now you can see here, this is the table we have to see. This is the table 0.01775. This is known as the normalized row stress value. So if this is the badness of fit, this value should be minimum. This value should be minimum. Now again you can see here, this is the, we have to see the S stress value. What we have said, the S stress value should be less than 0.10. So again it is saying 0.06. So our model is good. Our model is good. So it is S stress value, and from where you can find out this S stress value? This S stress value you can, if you will not able to understand from where you will find it, you double click it and then you can see here. You can see here, what is this? What is this? So the S stress is the misfit of solution. A lower stress means a better fit. So wherever we will find out the less value, it is our model is always better. Now we'll find, you can see here, dispersion accounted for, DAF. It is the goodness of fit. So from where we'll get this goodness of fit? If we will 1 minus normalized row stress, 1 minus normalized row stress value, then you can find out this value 0.98225. So this is a goodness of fit. So again, if you want to see this, double click and then you can see here what it is saying. What is this? What is this? The dispersion accounted for is 1 minus the normalized row stress, and it is a measure of overall fit of the model. So the higher the dispersion accounted for, the better the fit is. Also, what is the Tucker's coefficient of congruence? That is 0.99109. It is the square root of this. So if you will find out the root value of 0.98225, we will find out this value. It is again, it is a goodness of fit. So this value should be on the higher side. This value should be on the higher side. So our model is good. It is less than 0.10 stress value, badness of fit, and again it is 0.9910. 0.9910. Now you can see here, this is the dimension, 2 dimensions you can see here, 2 dimension. So before we'll compare this dimension, we'll find out the x and y axis, x and y axis. So this is for x axis, you can see here, and then we'll put y axis also. We'll put y axis also. So you can see here in this diagram, so in the x axis, our x axis data is here. Sorry, just a moment. Our x axis data. So you can see here the Trilo and Nirma. Trilo and Nirma, they are on the 4th quadrant. Eta and Supervar on the 1st quadrant. Ariel and OK is on the 2nd quadrant. Wheel and Reen on the 3rd quadrant. So these are similar, these are similar, these are similar, and these are dissimilar. Now how to identify these dimensions? How to identify these dimensions? So we have to show this value to the customers or the respondents, and then we will ask them. This perceptual map will show to the respondents, and we'll ask them why you have put this eta here. Why it is, what is the dimensions you have considered on the x-axis, and what are the dimensions we have considered on the y-axis. So on the basis of that, we can define the dimensions. It will come from the respondents only. So you can see here, these are the data you can see here. So Reen is minus 0.86 minus 0.02. So Reen you will find somewhere in all this is the negative value in both the cases. Nirma you can see here, for the dimension 1 it is positive, and for the dimension 2 it is negative. So Nirma is somewhere here, you can see here, Nirma is here, it is positive. For dimension 1 it is positive, and for dimension 2 it is negative. So this is the thing you can see here, and this is known as the perceptual map. And then you can find out how these different detergent cakes are positioned in the different quadrants. On the basis of that, you can find out where your brand is, and on that basis you can find out, you can compete, you can change your strategies, your policies, and you can compete with your competitors. So again we'll go to our PPT. You can see here, same thing we have calculated the number of brands. So number of dimensions, number of dimensions 2 we have seen. Then you can see here, this is these are the things, 28, 8 brands, sources 1, total active proximities are 28. Then you can see here, these are the data we have in 0.95 and all these things, these data are there. Okay, and then all these things are there. Okay, so how to write this? So this value is something, this stress value is, this is 0. Sorry, 623. This is the value 0.63. So suppose two dimensions we are considering how to report this data in your paper. So you can see, suppose two dimensions we have considered. One is the fabric care and the dirt removal capacity. So two dimensions we have considered and we have taken it from the respondent. So we have, what we have seen, the stress, S stress value is 0.0623. So this is the value we have got from our analysis. So it is good. It is less than 0.10. So it is acceptable. So our model is good. So what is our next explanation? It is saying the customer perception of detergent cakes, that is the Trilo and Nirma, Ita and Supervar, OK and Ariel, Wheel and Reen are similar in nature. So Trilo and Nirma, Ita and Supervar, OK and Ariel, Wheel and Reen are similar in nature. So what we are showing about, the Ita and Supervar have the high value for fabric care and high value for dirt removal capacity. Whereas Trilo and Nirma have high value for fabric care but the low value for dirt removal capacity. And Wheel and Reen have low value for fabric care and also low value for dirt removal capacity. Ariel and OK have the low value for fabric care but high value for dirt removal capacity. So this is the thing, this is our result, this is our output. On the basis of that, the company can take the appropriate decision. They can reposition their product and or they can launch a new product in the market, and whatever the modification in the policy or the planning, they can do it. Now again, we'll take the second example. You can see here, this is our second example. What it is saying, perceptual mapping of sneakers, one matrix. Again, it is one matrix: Puma, UCB, Adidas, Fila and Nike. So total number of pairs will be 10. Total number of pairs will be 10. So you can see here, so perceptual mapping of sneakers with special reference to Adidas and empirical study. So we have converted the case study into a topic. So again, you can see here the objectives are to find the comparable brands of sneakers, and second, to find the brand positioning of brands of sneakers. So these are the two objectives we have taken. Again, the same thing we have done, like Puma and UCB, towards 0 they are dissimilar, towards 10 they are similar. Same type of questionnaire we have designed and we have taken the responses. Now you can see here, now we have got this data. In the earlier example, the responses was from only one respondent. Now it is from the, like suppose 100 respondent, and then we have taken the average value of all the responses. So that's why these values are in decimal also, 3.1, 2.5, 2.4. So this is the aggregate data. The previous data was individual. So you have to work on Excel sheet. You have to find out the average value of all the respondents, and your data will look like this. So again, we will go for data analysis. So this is for for aggregate data. This data is for the aggregate data. So here the number of respondents are more, and we have taken the average value. You can see here. So UCB and Puma, suppose 100 respondents have given the responses. Someone has given 0, 1, 2, 3, 1 and so on. So we have taken the average value and it comes at 1.5. Similarly 3.5, 3.1, 6.2, 2.8 and so on. So this is the data. So earlier example was for the individual. This is for the aggregate. Now again we'll go do the same thing. So we'll for the sneakers. This is our data. You can see here in the variable view. Scale, we have all these data are there, and in the data view again you have to do the same thing. We'll go to scale, proc scale, then one matrix, then proximities across, and then define, and then we'll take all the data on the proximities, model. Again it is in interval scale. Lower triangular matrix, it is lower triangular matrix. Dissimilarities, there are how many brands are there? 1, 2, 3, 4, 5. So we'll go to 1 to 4. First we'll find out the dimensionality, how many dimensions are required, and then directly we'll go to plot, and in plot we'll find out the stress. So in stress we'll got that particular value. So you can see here, this is our data. This is our data. Again, you can see here, there is a, in the elbow method, 1 and 2, and the others are almost, these data are similar. So we'll consider 2 dimensions. So we'll consider 2 dimensions for this also. So I will close this. I will close this. And again, I will go to this and then scale. Okay. Same, 1 matrix. The proximities are in a matrix across the column. Then define. Now I am putting here 2 to 2. Minimum will be 2 and the maximum will be 2. And then continue. And then restrictions. No need to do anything. Then we can see here the interval. You can see here the stress convergence. It will converge or improve till 0.001. And less than that, it will stop. Minimum stress value should be for the perfect model 0.001. It should not be exactly 0. And the maximum iteration, the improvement will happen till 100 iteration if it is greater than 0.001. So that is the thing here. Then continue and then plots in which we have to find out the common space. Continue, and in the output we have to all common space coordinates, multiple stress measures are there, and then continue, and then continue, and then continue. So you can see here, these are the 5 cases. Total number of brands were 5. By a total number of brands are 5. Then sources 1 matrix is there. Objects are 5. So total proximities comparison is 10. So 5 into 5 minus 1 divided by 2. So that is 10. Missing proximities are 0. Active proximities 10. Now you can see here, this is the badness of it. Normalized raw stress 0.005. So 1 minus 0.005 is equal to 0.99414. And our this S stress value is 0.15. It is very good. 0.015 means it is 1.5%. 1.5%. It is very, very less than 0.10. So our S stress value is very good. And our, you can see here the dispersion accounted for value is 0.99414. It is approximately 1. And the Tucker's coefficient of congruence is also approximately 1.997. So these two are the goodness of it and it is the badness of it. And badness of it we have seen, it is 0.10, less than 0.10 is acceptable. Here it is 0.015, it is very less, 1.5. So our model is very good. Now we'll go to this common space and you can find out the diagram. So you can see here in dimension 1 minus, it in one dimension Puma is negative, here it is positive. Negative, both are negative. One is positive, one is negative. Here Phyla, both are positive. Here it is positive, here it is negative. Now you can find out this also by putting the dimensions. And you can see here. Okay, so we have to put this value 0, and then apply. Okay. So you can see here. So Adidas and Nike here in the 4th quadrant, UCB on the 3rd quadrant, both are negative. Here Puma is on the 2nd quadrant and Fila is on the 1st quadrant. So UCB and Fila, there are the far apart, you can see here. So there is a huge dissimilarity between these two. Then Adidas and Nike, there is a huge dissimilarity, and then Puma and UCB also. So these are the diagram perceptual map you can find out, and on the basis of that you can reposition your product, you can change your strategies, or you can develop a new product to fulfill the gap. So this is for the aggregate data when we have data of more than one respondent. This is for the aggregate data. Now in the in our types of multidimensional scaling, we have seen for the several matrices. In both the cases we have done the analysis for 1-1 matrices, 1-1 matrix. One is for individual, one is for aggregate data. But in both the cases, we had one matrix. Now for the several matrix, we have more than one matrix, you can see here. So for that we can do, there are, you can see here, 1, 2, 3, 4, 5. So 5 brands of toothpaste are there. So gender, these are the male and female, you can see here. So first we have taken the data of male and then we have taken the data of female. So these are the responses. So this is the response of first 5 is the response of one respondent, you can see here. The second 6 to 10 for the second respondent, and then 11 to 15 for the third respondent, and so on. So there are 10 respondents are there, in which 5 are male and 5 are female. 5 are male and 5 are female. So this is for the weighted multidimensional scaling for several matrices. This is for the several matrices. So this is the how we can do that. The same concept is there. We have to do the perceptual mapping of all these brands, how these brands are doing. So we'll go to analyze, and then we'll go to again scale, and then now we'll go for the several matrices. We'll go to multidimensional scaling, L scale. So click here, and then we'll take the data. Okay. Sorry, we'll take the data of all the brands. Okay, and shape, you can see here, this is the square symmetric, and then we'll go to model, considering it is your 2 to 2 matrix, that the data is interval, and we are finding the similarities or dissimilarities on the basis of Euclidean distance that we find out. Continue. Options. In options we find out the group plot and the model option summary. So these two things we'll find out. The remaining are same. As stress convergence, this is the value, and the minimum S stress value is 0.005. In case of several matrix, it is 0.005. And the maximum iteration is 30. So now continue, and then OK. So we'll go to the output. You can see here, this is our output. So the number of rows is equal to 5, number of columns is equal to 5, number of matrices is equal to 10. 5 male and 5 female. Then measurement level, interval, data matrix shape, symmetric, dissimilarity, then it is the Liptide, and then matrix, all these things are there. And then directly we will go to this table. You can see here the maximum iteration is 30, convergence criterion is 0.001. If it is less than this, then we'll stop this, and if it is greater than this, then we'll continue the improvement. Minimum S stress value is 0.005. Now you can see here the improvement. Earlier the S stress value was 0.38961, and the improvement happened, and this is the last improvement was 0.008. So it is less than 0.001. So we have stopped here. The improvement, and is S stress value is 0.36761. It is very high value, and S stress is a badness of fit, and it is very high. So our model is not good. Now again we'll go down. You can see here for the first matrix, the S stress value is 0.229 and the R square value is 0.34. What I have said, the R square value should be minimum, it should be 0.60. It should not be less than 60. It should be at least 60%. So again we will seeing a stress value, and the stress value is acceptable when it is less than 0.10. Here it is 0.237. So it is very high. So badness of fit is very high. R square is also not greater than, it is not greater than 0.06. So all these values you can see here. So now we'll see for all the 10 matrix you will find out. And in case of all the 10 matrix, you will not find the value is greater than 0.60. So nowhere the R square value is greater than 0.60. And the S stress value is less than 0.10. So in the overall value you can see here 0.3065, this is very high. This badness of it is very high, and our R square value is also 0.338. So it is far below than 0.60. So our model is not good. So in this case our perceptual map is not good. You can see. Also you can see here, this is the perceptual map of Pepsodent, Colgate, Close-Up, Aquafresh and Colgate, all these things. So this is the perceptual map. The explanation or the result or the output, explanation of output will be same, but our model is not good because our R square value and S test value are not as per the criteria. As per the criteria it is not good. Okay. So this is all about our multidimensional scaling. I have given the considered 3 examples. One is for individual, second is for aggregate data, and third is for our several matrices. Weighted multidimensional scaling for several matrices. So thank you very much.